talk about all the different ways to find intercepts in Algebra 1, from the very easy to the more tedious. We'll start with this first graph. Now remember, when we talk about x and y intercepts, we are actually talking about the point where our line, our function, our graph intersects with both the x and y intercept. So in this case, we have our x-intercept, because that's where it crosses the y-axis, and our y-intercept. Now in both those cases, the x-intercept and the y-intercept are a point. So in this case, the x-intercept is 2, 0, and the y-intercept is the point, and the y-intercept is the point 0, negative 5. So we can see those 2 points just by where they intersect. In our second graph, we see one of the difficulties about finding the x and y-intercept from a graph. We can see the y-intercept. It is at the point 0, 2. And it's pretty obvious. But we can also see the x-intercept, but in this case it's not quite as obvious. Now we can make an estimate, but just by looking at the graph itself, we can't tell. That's the downside of having a graph, is that you can't always find it. Now, you can do some interpolation, like you can see the next point here, and you can pretty much guess that it's going to be at 2/3, but you're not real sure about that. So the downside of finding the x and y intercept from a graph is that you don't always have it, or you don't always have both of them. But if you have a graph, this is one way, and it is a very simple way to find the x or the y intercept. Next, we'll take a look at how to find the x and y intercepts from a table. Now, as I said earlier, it's where it crosses the x-axis that we're looking at the graph. And you may have noticed that each of our x-intercepts before would have a number on the x-axis and then a 0 here. And our y-intercept would have a number here in the y position and would have a 0 in the x position. So that's your key. You look for those features when you're looking for the intercepts. So as we look at this first table, we see the ordered pairs negative 22, negative 16, 0, negative 10, 3, 0, 8, and 4, 10. So immediately we should notice the 0 in the y position here and the 0 in the x position here. So when we think of those two ordered pairs, we have 0, 8. So let me do a little quick drawing here. If 0, 8 would be 0 and 8 right there. So that would be our y-intercept. So again, we look for the x equals 0 to give us our y-intercept. And then we look at negative 16, 0. That would be way over here, negative 16, 0. So again, we look for the y equals 0 to give us our x-intercept. So our x-intercept is negative 16, and our y-intercept is 8. Here we have our second one, and we look closely, we can see 0 right here. So we have the point 0, 5, which is going to be something. So if you think of 0, 5, that's going to be our y-intercept. So our y-intercept is 5. But what you don't see is an x equals 0. There is no x equal on here. So you've got to kind of figure out what it would be. Sometimes you can figure it out and it's actually there. Sometimes like this, it's not going to be a whole number. You can see this is going negative 3, 1, 5, 9, and this should be 13, which would make that a little bit easier problem. But as we go down, it goes negative 2, negative 1, 0, 1, 2. And you can see this is 0, 5, 1, 1, 2, negative 3. So the 0 will be somewhere right here between the 1 and the negative 3. The problem is you can't tell. You can kind of hope and look, but at the very least, it's going to be a decimal in this case. So that's the downside to finding the x and y intercepts from the table, is that most times they're there, but a lot of times, especially if it's not a whole number, then it's not there, and it becomes a lot more difficult. You can logically work your way through it, you have to interpolate, you have to do some other things, but it's not there. For this last one, there are no zeros, so it's not here even at all. So at that point, you can still use the table, but it's not going to be quite as easy. You can tell there's a 0 here. Now the good thing is the 0 is halfway between negative 1 and 1, so you can logically determine that if 0 is halfway between 1 and -1, that means that the x-intercept is going to be halfway between 2 and 3, which will be 2.5. So you can do that, but even that can be kind of scary to determine. But if it works out, it works out. And then 0, I didn't put that on here, so it goes 3, 2, 1, 0 is right there. So that means it's going to be halfway between 1 and -1, so halfway between 3 and 7 is 5. And so you can determine that the y-intercept is 5. So even though it's not there, sometimes you can work your way through, determine the pattern, and you can find the x and y-intercept that way. Now finally, we'll look at finding x and y-intercept from an equation. The most tedious of the three methods, but by far the most useful. It'll work every single time if you have an equation to find the x and y-intercept. But it does require you to plug in some things in. So the key to remember when we do this is what we already talked about, that your x-intercept is where y is equal to 0, and your y-intercept is where x is equal to 0. So you have to remember that and plug things in, kind of like when we do function notation. We're going to plug something in, get the result out. We'll start with this one, y equals 2x minus 8. Now, you probably have already realized that the y-intercept is found right here, because when we talked about y equals mx plus b, b is the y-intercept. So that's a nice thing to know. And if you do know that, then you automatically can find the y-intercept as -8. That's great. But in most cases, you have to find it. And the way you find it is to remember what we talked about earlier, that the x-intercept is where y equals 0 and the y-intercept is what x equals 0. So I want to start off by finding the y-intercept, even though we already know the answer. That's where x equals 0. So if I take this and I replace the x with 0, now I have y equals 2 times 0, which is 0, minus 8, so y equals -8, which we knew it was. But we can do the same thing for the x-intercept. By replacing the y with 0, now we have an equation we can solve, and we should be able to solve this one. Bring the 8 over to this side by adding it. So 8 equals 2x, so then divide by 2, and x equals 4. That means the x-intercept is 4. What's nice about this is if we were to graph it, the y-intercept would be at -8, the x-intercept would be 4, and we'd have our equation like that. So that's something we'll get into later, but that's how it works. Now we can look into the second one, and it wouldn't be a normal day if I wasn't trying to mess you up on one of them, so we'll try that as well. Now luckily we have the y-intercept here. So the y-intercept is 7. We know that. And again, we can prove it by plugging in 0, which gives us y equals 0 plus 7, so y equals 7. So we know that, not a big deal. So now to find the x-intercept, we're going to plug in 0 for y. Now, some of you may already be noticing this one's going to be a little tricky. We're going to subtract 7, get -7 equals -4x. Then we divide by -4, and this is one where we don't get a whole number. Sometimes the x-intercept is not going to be a whole number. Sometimes the y-intercept won't be a whole number. In this case, the x-intercept is not. So we just have to solve it using our math to find it. So -7 divided by -4, we'll just leave that as positive 7 over 4. Now this is a case where if you really wanted to change it to a decimal and you knew you could do it easily, go ahead. There's no need to, but if you do want to change it, that becomes 1.75 equals x. That means your x-intercept is 7/4 or 1.75. And again, if you were to graph that, that would mean your y-intercept is 7, your x-intercept is 1.75, so you get a line that looks something like that. But that's not necessary for today. And finally, you get one like this. 3x plus 2y equals what? -12. Now, this one is not in y equals mx plus b form. So just like you can't look at this and go, well, that's the slope, because it's not, you can't look at that and go, well, the y-intercept is -12, because it's not. You have to solve it mathematically. So again, it goes back to what I just said. We're going to start by replacing the y with 0 and solving it. So 3x plus 2 times 0 gives you 3x plus 0 equals negative 12, which means 3x equals negative 12, which means when you divide by 3, you get x equals negative 4. That means your x-intercept is negative 4. We'll do the same thing for the x-intercept, or the y-intercept, sorry. We'll replace the x with 0. So we have 3 times 0 plus 2y equals negative 12. So that gives us 0 plus 2y equals negative 12. So 2y equals negative 12, and we divide by 2, and we get y equals negative 6. So the y-intercept is negative 6. That will work for any equation. By just plugging in the x or y, you can find the x-intercept, you can find the y-intercept. It doesn't have to be in a specific form, though some forms will give you the answers that you're looking for very quickly. Next time in class, I'm going to take a little time to show you a method that I playfully call the magic finger method. It works really well. Kind of bypasses some of the math and gives you a quick and easy way to do it. But this is what's going on. Until then, plug it in, plug in 0, find your missing value. So that's it. We have 3 methods we find the x and y intercept. We'll go over them real quickly. For a graph, you're just going to look and find the points of intersection. For the table, you're going to look for zeros. And when x is 0, you have the y-intercept. And when y is 0, you have the x-intercept. And finally, for an equation, you're going to substitute the 0 for each variable, and then solve. And then you'll have it both, and it'll be very simple to do. So make sure you try all those. Make sure you find the easiest route for you. There's no need to go graph or do anything weird, but those are going to be the easiest way to go about finding it.